So again, this is all about absolute value. Now, before I go over that, we are going to take notes. So if you do want to set up your notebook and set up a page at the top, put absolute value equations, because that's the one specifically I'm going to take notes on. And I just put this over here just to remind myself it's a Zoom. These are Zoom notes, and don't forget your page number. So absolute value equations, and then put your Cornell notes line there. So absolute value equations, page number, and we'll go over that here in a second. Okay, so absolute value. Absolute value just means what is the absolute value of something. Okay, so and when we say absolute value of something, we're talking about how far away. Let's say I drew a number line, and I wrote 4 over here, and let's say -7 over here. When we talk about absolute value, we're talking about what is how far away is something from 0? Like 0 is like the absolute, 0 of something, right? It's the one number that means we have nothing. And the absolute value just means how far away is a number from 0. Well, if I asked you to count how far away 4 was from 0, you would say, well, it's 4. Okay. If I asked you how far away is 7 from 0, you would say it's 7. Okay. So because you would count 1, 2, 3, 4, 5, 6, and 7, 7 spaces away. So in other words, if I said, what's the absolute value of -7? You'd say it's 7. And the way we notate that is using these bars that look like that. Okay. And the same thing with the 4 is we'd say, what's the absolute value of 4? You put the bars around it and you say it's 4. So no matter what, it will always be positive. Okay. So that's kind of the whole point of that, is that anytime you take the absolute value of something, you're going to end up with a positive result. Okay. Now, when you're solving equations, that doesn't mean that all your equation answers are going to be positive. It's not necessarily the case. All right. And that's what we're going to look at. All right, so first looking at the IXL assignment, you literally are just answering the question, what's the absolute value of the number? Well, absolute value of -2 is just +2. What's the absolute value of -4? Well, it's just 4. What's the absolute value of 9? What about +9? Well, it's still just 9. Okay, so really, if you think about it, L, you're just writing the number and putting the positive result, okay? So that's pretty much what this is about, okay? All right, so after you're done with that, then the next thing is, here, okay, so the next assignment will be the Edpuzzle, and it'll explain how to do equations. And so I'm gonna give you some examples of equations from Deltamath. Now, when you guys work on this one for 9A, just remember that this is the type of assignment where you just get one attempt, and even if you get it wrong, you're still done. Okay, it might not have the little green check mark over here when you finish that problem, but it should say done right here. As long as it says done, then you're good. So like this is not an assignment where you'll, unless you get everything correct. If you get everything correct, then you'll get 100%. If you don't get it correct, it might say less than 100%. Okay, but the key thing is just make sure that you see done on all of those. Again, if you get it right, you'll see a green check mark. All right, so this one, the second one, which is for the assignment due on Thursday, that one you do have to get them correct. And remember, you can always tell the difference when you look at the bottom here. If it says like problem 1 out of max 1, that's when you know you only get like 1 try. Okay. So let's go over, well, that's basically what we're going to focus in on, is problems like this. Okay. So I am going to pick another example, which is very similar to that. Actually, you know what? I'm just going to come up with my own. All right. So here you can see we've got absolute value now with some unknown number. All right. So before we take notes on how to do these, kind of want you to understand what that means or what it could mean. All right, so remember, anything that goes inside those absolute value bars ends up becoming positive, right? So you have to think to yourself, what would I add to 2 to make this equal to 3? Well, you'd add 1, because 1 plus 2, in other words, what would I plug into x? Okay, so here, 1 plus 2 is 3, and then when I take the absolute value of 3, well, that is 3. So that means for this one, that x equals 1 is a possible solution, right? But that's not the only solution. There is another solution. Because you remember, it doesn't matter if the numbers in here are negative. Like if I get a -3 here, I can still have the correct answer. So if I, let's say, what would I have to add to 2 to make it -3? Well, -5 plus 2 is -3. So now if I add these two together, that's -3. And now the absolute value of -3 is +3. So that also works, which means that not only is +1 an answer, but -5 is an answer. So you have 2 solutions, not just one. Okay. So a lot of times most of the time, I should say, not every time, most of the time with absolute value equations, you're going to have 2 solutions. 2 solutions. All right. And so there's these steps you're going to go through when you're actually going to create 2 equations in order to find those 2 solutions. So you can see here, I kind of just like thought up like what kind of numbers would work, but there's a way to do this algebraically so that you can just follow the steps and find the solution. All right. All right. So that's what we're going to do. All right. So again, the first problem looks like this. So we'll come up with one that looks very similar to that. So example 1, we're going to do the absolute value of, I don't know, x plus 3 and then minus 5. And I think it was, what was it, 0 on the other side there? Yeah, just equals 0. All right, so here's the deal. You want to, when you're dealing with absolute value equations, you want the absolute value by itself. By itself. Or that word we like to use is isolated. Okay, so what I'm referring to is this part here. So just that part that's inside the bars, all right? That's what we want by itself. So in other words, that number that's outside of the bars, anything outside, we want to cancel that out and get it, basically remove it from the left side of the equation. Because remember, if I divide this equation down the middle, right on the equal sign, anything outside needs to go. Anything inside, we're not gonna touch that. Okay. So here the first step is, if that's -5, we want to add 5. So just like any other equation, we would add it to both sides, and then we bring the absolute value of x plus 3 down. Just add up the right side, so 0 plus 5. Okay, now, as long as we don't have a number on the outside to the left, or negative, or a number on the right side of the absolute value, now what we can do is create 2 equations. The way we do that is we split this up. Okay, so now the first equation, we basically just copy the same thing without the bars, okay, without the absolute value bars. And Adam, to answer your question, yes, we would always get 2 answers. All right, the second equation, repeat the same first part of the absolute value, but on the right side, this number is now negative. I basically will change the sign of the value on the right. So that's kind of the key step. Make sure that your second equation, you want to change that value. So on that note, if that number here is negative first, then you got to make sure that the other one's positive, in other words. All right, so now I just solve it simply by subtracting 3 on both sides, and x equals 2 here. Do the same thing, minus 3, both sides. And now negative 5 minus 3, I'm going to add those up because they are the same sign. And now I get x equals 2 and x equals negative 8. Okay, so I'm going to pause just to give you guys a chance to catch up. Okay, so I'm just doing this for the recording. Again, I set the second equation for absolute value. And again, the same thing like before. We had to get rid of that number on the right. That's on the outside, which I subtracted this time. And then once we have the absolute value isolated, then we have negative 5 on the right, which in the first equation, I write negative 5. But again, when I split it into the second one, I change the sign of that second number, just like we did up here, whereas the first one was positive and the second one was negative. Okay, so that cancels out. And then I still have 3 times x minus 7 equals now negative 10 minus 5 would be negative 15. And again, now, let me just point this out. These two numbers are outside. These terms are inside. Okay. And now here, since it's being multiplied, you want to do the opposite of the operation, or opposite of that, to get rid of it, which would be to divide. So here, I'm going to divide both sides by 3. Now, this cancels, and now I just have only x minus 7, the absolute value, on one side. Now it's isolated. Okay, and I apologize that every example has had 5 here. That's not on purpose. It just happened to have a 5. Okay, but that will be a different number sometimes. Okay, so now we can split it into 2 different equations. First one, again, on both of them, you will repeat the x minus 7. Oops, sorry, not x equals. X minus 7 here. And then just to highlight what we've been saying, the first one will be the same sign. The second one, you want to change the sign. All right, then I just simply here just solve each equation. So now here, add the 7, x equals 2. And then here, add the 7, and x equals 12. All right, so when you guys are doing Deltamath, however, and I'll come back to this, by the way, just so you guys are writing notes. When you write in your answer for Deltamath, let's just say the answer for this one is 10 and 2. The second answer, you're going to want to hit the comma button. As soon as you hit comma, boom, it creates another box for an answer. And then you can put in your second answer, okay? So if you're like, hey, how do I do 2 answers? Just literally hit comma, and then your second answer come up. And notice how I did not put x equals. You don't need to do this. And if you guys are kind of gotten used to Deltamath by now, you've never had to like say x equals, a equals. You literally just put your numbers, okay? Equals negative 10. Okay, so again, remember that anything inside, we're not going to touch it, all right? So what do we have on the outside? Well, we have a 4 on the outside. Actually, let me put the arrow on the top because we're going to write some things underneath. So that's outside. And if you guys don't notice, there's a negative here. And it's just not just a negative, it's actually a negative 1. So in the front of those absolute bars, you have negative 1 times the absolute value, right? So that's also outside. Now, the one that is being added or subtracted, that's the one we want to deal with first, which would be this 4. So here, first, we're going to subtract the 4 from both sides. Sorry for my shaky table. It's extra creaky this morning. All right, so then I bring that down, and I have the -1 times 2x plus 3, and then -10 minus 4, -14. Now, just like I had a number over here in front that's being multiplied, I have the same thing here, so I'm going to divide it. And remember, when you divide on both sides, you divide the same number, not the opposite. So the same sign of -1 on both sides. Okay, so that will cancel out that number there, or at least turn it into a 1, so we doesn't mess with our equation. So now we've got the 2x plus 3, or the absolute value of 2x plus 3 isolated. -14 divided by -1 is +14. Now we can split it. Got it? Now it's by itself. All right. So remember, that's the goal. That's what you're trying to do to get the absolute value isolated. Always want to get that isolated by itself. That's your goal. And in this case, you had 2 steps to do that, right? I had to get rid of the 4, then I had to get rid of the -1. On the last problem, I had to get rid of the 5 and then the 3. And that could be on the other side. It could be like a number being multiplied here in the front, and then maybe on the other side, kind of like these problems, you might have it being added on the other side. Still follow the same steps. Still add or subtract this number, and then divide the other number. Okay, so now we can split it. So now we have 2x plus 3 equals +14. And then on the second one, 2x plus 3 equals -14. So again, this is where we switch the signs. So now we just solve it. So -3 minus 3 on both sides of each equation. So you can see I'm kind of going both at the same time. And then, so that's 11. And that's 2x divided by 2. And then over here, we're going to have -14 minus 3, which is -17. And then 2x divided by 2. All right, 11 does not go into 2, or 2 does not go into 11. So we just leave it as a fraction, an improper fraction. So that's our answer, 11 halves. Okay, and then here, same thing. 2 does not go into 17. So I can just leave my answer as -17 halves. If I want, I can make this a mixed number, although not necessary, just good practice. How many times does 2 go into 11? Goes in 5 times. And then what's the remainder? Well, 1. So 5 and 1/2. I mean, either answer is fine. Okay, or 5.5 if you divide it on the calculator. Okay, how many times does 2 go into 17? Goes in 8 times, but remember this is negative now. And then how many left over? Well, same thing, 1/2. So -8 1/2, 5 1/2, or you could have put -8.5, all acceptable answers. Okay. I say that just because in Deltamath, it'll take either one. All right. Matter of fact, I don't know if it'll take half answers or mixed numbers. I think it'll only take improper fractions like this one and decimals. Okay, so those are the type of examples that you guys are going to see in those assignments.